Now the last submodule of this GSM network optimization and drive test, that is the troubleshooting part 2. Here we will discuss the speech quality troubleshooting, handover failure troubleshooting, cell load balancing troubleshooting. How we can balance the cell load where one cell is higher load and other cells are having less load. So first, these are the some parameters, speech quality parameters: RX qual, frame erasure rate, FER, echo and distortion in the system, audio holes, blank period of speech due to malfunction of transcoder boards or PCM circuits, voice clipping occurs due to the improper implementation of discontinuous transmission. And the last one is the mean opinion score. This is the speech quality parameter. It is a ITU standards parameter for estimating the speech quality. Sorry. The mean opinion score, that is the ITU parameter, where when it is a 5, that means the speech quality is excellent, and if 1 MOS, then it means it is a unsatisfactory speech, not understandable. So these are the how we can estimate the speech quality, whether it is a good or bad, or any echo is there, or clipping is there any, right? We can check by using these different parameter in the radio optimization drive test tool. First parameter is RX quality, second parameter is the frame erasure rate, third one is the frequency hopping, fourth one is the discontinuous transmission. If the RX quality is very high, right, that means RX quality is high and FER is low, and there is no FF frequency hopping and there is no DTX, that means there is a speech bad problem. If there is a speech bad problem, but parameter is like that, RX quality high, FER low, frequency hopping is no, DTX is no, then there is a reason is for air interface impairment. There is any problem in the radio part. Second, just like this, if RX quality is high and FER is also high, right, and FH is no, frequency hopping and DTS is no, then there is a severe air interface impairment, because quality is very good, but your FER and very high, frame erasure rate is very high. That means severe air interface problem is there, radio problem is there. Maybe there is a faulty TRX, maybe other things is there. Second one is the region of bad speech, when RX quality is low and FER is high and DTX and frequency hopping no, there is a transcoder error, there is a transmission system error. So we can recognize by seeing or we can identify by seeing the parameter in the drive test tool, live drive test tool, RX quality, FER, and frequency hopping and discontinuous transmission, so that we can recognize, and we can check where is the problem, and whether it is a radio problem, transmission problem, or any hopping implementation problem. Okay, or any voice activity detector problem. Voice activity detector installed in your handset that detect voice, whether it is a voice or not voice. It actually WAD is used in the discontinuous transmission mode when they is active. Now the troubleshooting handover problems, how we can troubleshoot and optimize the handover issue. So then they decide the target cell for handover in the trouble spot. What are the source cell and what are the target cell? Check whether handover margin can be reduced to improve the quality or increase to avoid ping pong. So one of the region of handover margin, there is a best way to handover from lower quality to higher quality cells. You can play with the handover margin so that the cell handover whenever it from the lower quality cell to higher quality cell. If handover margin settings are proper and still handover is not occurring, then it could be a problem of handover decision or processing parameter at the BSC level. Handover success rate, maybe it also, if HOSR will be good, the T-stage drop will also be good, right? If handover success rate is bad, degrades, that means your call drop is also degrade, means your handover success rate and call drop are interrelated to each other. Whenever your handover fail is higher, in that cell, your T-stage drop will also be higher. So reasons for poor handover success rate, these are some regions in GSM network. The improper neighbor planning and co-BCCH basic issue in the neighbor list, parameter check, all the parameter whether DTX on or power control is enabled or not enabled, and HSN class. HSN class means your planning of HSN and MIO in the neighboring base station so that the interference of the TCH eruption may be avoided. Lack boundary, sync mismatch, overshoot, hardware issue, low coverage, external sales data mismatch in the BSC or RNC. These are some reasons for poor HOSR. So optimizing the neighbor list in the dedicated mode, actually, we are defining more and more neighbor in the source cell. There is a problem by defining more cells because mobile in the dedicated mode measure the BCH of the neighbor cells, and the list of broadcast channel to be BCH is to be measured is informed to the mobile in the system information type 5 message, which can have the maximum 32 neighbors BCH. Right? The mobile has to report the measurement of neighbors to the network after every 480 milliseconds. That means after every 104 TDMA frame. The mobile will take several samples of the neighbors and average it and then send the report as one value of the RX level of the neighbor with the minimum requirement of measuring at least one neighbor in one TDMA frame. So, more the BCH in the neighbor list, less will be number of samples. RX level samples, RX quality samples. If the mobile just meet the minimum requirement, then for a neighbor list of 32, right, only 3 to 4 samples per neighbor will be available and 12 to 13 samples per neighbors with a list of 8 neighbors. If the sample collected are less, it means the average value reported will not be authentic and can result into the ping pong effect of handovers. So the neighbor list must be optimized with the minimum best possible numbers. Minimum best possible numbers. Solution for improving the HOSR. First, the retune the neighbor list, reduce as minimum optimize. Okay. Avoid co-BCCH basic neighbors and also avoid extra neighbors. Delete long distance neighbors. Check whether the neighbor defines both way or not, or we can say remove one-way neighbors or add both-way neighbors. If there are high, fail to delete and create neighbors. Handover power boost parameter should be enabled so that the handover command can be sent on the maximum power. External cell data must be corrected in the BSC. so that the inter BSC handover can be easily taken place. Next is the cell load optimization. How the load of the cells can be optimized by using different techniques, by using the cell selection, reselection parameters, by changing the handover margins. We can balance the cell load between one cell to another. The cell loading, cell C1, cell C2 are reporting blocking. You can see here, and cell 3 having the cater the capacity. They can cater the capacity actually. Okay, so still C1 and C2 reporting blocking. Why? How can we change this scenario? C1 and C2 cells having higher traffic, and C3 cell in between them having lower traffic. So how can we optimize the cell load between the C1, C2 to C3 by using the parameter cell selection and cell reselection parameter, so that the one of the cell can early select the cell and another can select the long far away users. So one of the cases is by using the cell selection reselection parameter, we can select the cell, right? More neighbors are good, and near the equal power levels will result into excessive reselection. So by changing the handover margin, we can also optimize the cell load between C1, C2, and C3. The handover margin is the main objective to avoid ping pong effect of the handover on cell periphery when the power levels of the two cells are near to the equal. So due to multipath and mobility, this will result into frequent handover between these two cells. So we can, that in that scenario, we can also change the handover margin so that the frequent handover could not take place. Thanks for listening.